Okay, so we have some puzzles to solve here. They tell us this is a circle, O is its center, its radius is 3.25, QR is 2.5, and RS is 4.7. Now we have some things to figure out. The trouble with these questions is there are not fixed procedures for them. You just have to be kind of agile and know your rules of circle geometry and be persistent if you're not immediately sure what to try. Let's see. The length of PQ is the first thing they challenge us to find. This. That side is PQ. What relationships does it have to other sides? Well, one of the rules in circle geometry says if you have a triangle inscribed in a semicircle, meaning one of its sides goes right through the middle of the circle, then that will be a right triangle, guaranteed every time. So we have a right triangle here. We know one of its sides is 2.5. Because it's a right triangle, the Pythagorean theorem would work if only we knew another side. Is there any way that we could fill in, like, PR? If we knew what that was, then we could use the Pythagorean to get PQ. There is a way to do it. They told us the radius is 3.25. That means from R to the center is 3.25. From the center over to P is another 3.25. So this side is a grand total of 6.5 centimeters. And now we have an equation to play with. I'll call this side little r. We can say r squared plus 2.5 squared equals 6.5 squared. 2.5 squared is 6.25. Sorry, that's a plus. 6.5 squared, I'm going to need some technological help. 42.25. Subtract 6.25 from each side. R squared is, oh, nice, 36. So R is simply 6. I just realized I probably shouldn't have used little r because people think of that as the radius. I meant it to be this side here, which is across from angle R. Not a great choice now that I think about it. But we got that side at 6 centimeters. Now, the measure of angle QPR, this angle. Well, it's a right triangle and we know several of its sides, so we should be able to do this using a little trig. If you're standing here, then you could do, say, that this side is the opposite and this side is the hypotenuse. Therefore, sine P is opposite over hypotenuse. There. 2.5 divided by 6.5 is 0.385. Second sine. That angle has got to be 22.6 degrees, or actually, they said to the nearest whole number, so 23 degrees ought to do it here. SQR. SQR is in this corner. Oh dear, I'm not sure what to do with that. This is not a right triangle at all. We don't know the length of that side. Don't know that angle. 2.5, that's 4.7. If we knew a single angle, then, oh, I see what it is. Got it. Okay, angle P is 23 degrees. There is a rule called the angles in a circle theorem, which says if you're looking at a chord, one moment, I'll mark this for you. If you have a line like this, which is called a chord, QR, that red line, if you're standing on a circle looking at that chord and you think that it's 23 degrees wide, and then another person standing somewhere else on the same circle looks at the same chord, they will get the same angle. This person will agree with you that that chord looks 23 degrees wide. Now that we have that, you see what we've got? We have 2.5 across from 23 degrees, and then we have 4.7 across from the angle we need to find. We have two opposite pairs, which means the sine law can do this for us. We can set this up as, I'll do it over here so it's closer to the picture I'm using. We can say sine 23 over 2.5, that's this angle over this side, equals sine q, the angle we're supposed to be finding, over 4.7. So we cross multiply 4.7 times sine 23 divided by 2.5. We get sine q equals 0.735, and then arcsine of that gives 47 degrees. Q should be a 47 degree angle. So like I say, there's no step 1, step 2, step 3 for getting through these. It's a matter of have the rules as memorized as you can get them. Have a cheat sheet that has all of them on it so that you can quickly refresh your memory and just look for new ideas. And jump around, try different things, experiment. You may end up drawing the same picture 3 or 4 times just because you've tried a couple of things that didn't work, and then you backtrack. And be persistent. Keep trying something different, and if you're truly stuck, get away from it for 10 minutes, think about something else, and let your subconscious chew on it. Sometimes these puzzles come down to an aha moment that sometimes you can't force that to happen. It's just a matter of having the rules in your head and giving yourself some time to get creative.